So number 81, okay? SDRAM, diba? So this is synchronous DRAM, diba? So ibig sabihin. So that is letter B. No, so this is B. Okay. Next number 82. Okay. So number 82, this is a storage hydroelectric power plant. Hinahanap lang yung kilowatt output, diba? So again, so remember, so the output power is just given by efficiency times Q omega H. No? Kung i-check nyo yung given, nakalagay dyan, efficiency is 75%. So our volume flow rate, okay, so it's given by 1,000 cubic meters. No? So cubic meter per minute. Okay? So kailangan natin i-convert sa per second. So we have 1 minute for every 60 seconds. Okay? So then this is multiplied by, so again, so let's use 9.81. So again, para kilowatt kaagad yung makuha natin. So kilonewton per cubic meter. Okay? So then we have an effective head of 100 meters. Okay? Pag sinolve ito, so again, this will be kilonewton meter per second. So that's kilowatts. No? So you should be able to get 12,262.5 kilowatts. Okay? So kaya yung sagot natin dito is letter C. No? So okay, so typo lang yung nakikita nyo dito. So, okay, so that should be 12. Okay, so this should be comma. So then this should also be comma. No? Okay? So siguro doon sa pinagkunan ko, kinapipis ko lang kasi yung tanong na yan sa material. Okay? So next number, 83. Okay? So we have this one. So ito may troubleshoot. This should be 238 million. Okay? So kaya kasi masyadong maliit to, 'di ba? For a 55,000 kilowatt power plant, this is very small. Okay, no ka ba? For a year kasi annual output 'yan, 'di ba? Okay? Kasi ito nasa ilang oras lang kaya natin i-produce to from 55,000 kilowatt, 'di ba? Okay? So kaya alam natin, so troubleshoot to. This should be 238 million. Okay? So yung tanong is capacity factor. Diba? So ano yung formula natin for capacity factor? Okay? So again, that's the total energy produced divided by installed capacity multiplied by the period. Diba? So again, so number 83. So this is 238 million. Okay? Kilowatt hour. So then divided by the installed capacity is 55,000. Okay, so kilowatts. So and again, this is annual output. So therefore, the number of hours, diba? So per year is 8,760 hours. So okay, this will be in kilowatt hour. Okay. So then, multiply lang natin ito ng 100 to get the percent value. Okay, kasi naka-percent yung choices. So you will get 49.4. Okay. So this is 49.4%. Okay, so this is letter A. Next number, 84. Okay. What do you mean by demand? So okay, pag sinabi natin demand, this is power. So alam natin this should be kVA load. Ito lang naman yung power do sa choices. Okay. Number 85, circuits for a show window are calculated at which of the following. So ito nasa PEC lang to. Okay, tama ba? So 84 is D. Sa akin yung number 85, di ba? So reference natin dyan is PEC 2017. Okay? So ito ay section 2.20.2.86, di ba? So sinasabi doon, so that show windows, di ba? So shall be rated, di ba? So at 300, 1,000, okay, so 200, no? Sa akin, so this is volt ampere. Okay, so per linear 300 millimeter, diba? So of show window. Okay, tama ba? So ito yung makikita nyo sa PEC 2017. So therefore, this is letter B. Okay, tama ba? So now, so itatandaan nyo na, kasi noong April 2022, meron lumabas na ganitong problem. So given kung gaano kahaba yung show window, so ang tinatanong is ano yung rating, di ba? So meron din atang tanong na ilang branch circuit yung kailangan and so on, di ba? So yung tatandaan nyo lang dito is ang una nyo kailangan malaman dyan is kung continuous ba or non-continuous yung given sa atin na show window. Okay, tama ba? Pag continuous, i-multiply nyo pa kasi ito ng 1.25, ng 125%. Pag non-continuous, hindi nyo na kailangan i-multiply. Okay, tama ba? So kasi remember, continuous load so is 125% of the ampacity. Diba? Okay? So yun yung tatandaan nyo. So kaya, so hindi lang ito basta 200 volt amperes. No? So again, so pwede rin itong ma-multiply sa 1.25 depending kung continuous load siya or not. No? Okay? Number 86. Okay? So ito yung number 86 natin. So given tayo ng input power, 4.5 kilowatts. Output power, 5 horsepower. Hinahanap yung efficiency. Okay? So again, so this will be output power, so divided by input power, so multiplied by 100. So again, from the given, this is 5 horsepower. Lipat ko lang sa kilowatts. No? So kasi naka-kilowatts yung input, so para hindi na natin kailangan i-convert yung input. Diba? So the input power is 4.5 kilowatts. Okay, so just multiply this by 100. So you will get, this is 83%. Okay, so this is letter B. No? Number 87. Okay. So a 480 volt motor with a full load current of 25 amps requires a disconnect rated at which of the following? Diba? Okay, so now, so number 87, so gagamitin natin yung sinasabi sa PEC 2017. So section 4.30.9.10A. Diba? Okay, so yung sinasabi dito is that disconnecting means okay, so off or for okay, so for motor circuits.
Wait,
Okay, so for motor circuits rated, okay, so rated 1,000 volts nominal, okay, or less, okay, so shall have an ampere rating, okay, of not less than, okay, so 115%, okay, so of the full load current rating. So full load current rating, okay, so of the motor. No. Okay? So kaya guys, so yung disconnecting means natin dito for this problem should be 115%. So again, the full load current is given by 25 amperes. Diba? So again, so don't forget this. Pag disconnecting means 115% lang. And this is not less than, diba? So kaya ibig sabihin, so 25.75 amperes or more. Diba? So kaya ibig sabihin ang gagamitin natin so is 30 amperes. Kasi ito yung pinakamalapit sa choices na mas mataas sa 28.75. Okay? So this is letter D. Okay? Nakaba? So actually kung 125% yung ginamit nyo, safe pa rin kayo kasi 30 amperes pa rin probably yung pipiliin nyo. Okay? So pero remember, pag disconnecting means 1.15 lang yung i-multiply nyo. No? So 115%. Okay? So common mistake yun ng mga estudyante pagdating sa disconnecting means. No? Number 88. So dito may troubleshoot din. Okay, so kasi walang lalabas dito pag sinolve ito as S, no? So again, so troubleshoot dito, this should be 14 pole. Okay, nakuha ba? Nawawala yung 1. Okay? So I troubleshoot. Number 88. Okay, so this should be 14 pole. Okay, so let's try to solve. So again, synchronous speed is 120 F over P. Diba? So then the rotor speed is 1 minus the slip. Okay, so multiplied by the synchronous speed. No? So 1 minus the slip times the synchronous speed. So this is 1 minus S multiplied by 120 F over P. Okay, so then, so for the given, so again, the slip is given as 5%. So that is 0.05. No? So multiplied by 120. So frequency is 60 cycle. Number of poles, again, ang gagamitin nyo ay 14. No? So pag sinolve natin ito, lalabas yung 488.57 RPM. Okay? So this is letter B. Okay? So that's number 88. Okay? So next, diba? So the problem number 89. Okay? So blank refers to an AC generator. This is an alternator. So actually sa choices, kung mapapansin natin, isa lang naman yung generator dyan. Diba? So we have the alternator. So this is letter D. Okay? Next, number 90. Diba? Sa number 90, may troubleshoot din dito. Okay? So although hindi naman siya masyado nagmamatter kasi halos pareho lang yung lalabas. Sa akin, this should be 200 amperes. Okay? Diba? So isa rin yan sa mga common troubleshoot natin. Diba? Sa akin yung pag may mga doubling digit, diba? So minsan nababaliktad sa EE. Okay? So we have, ang tatandaan nyo lang dito, diba? So sa test sa open circuit sa short circuit test ng alternator, is dapat yung open circuit sa short circuit natin are done at the same amount of the field current. Diba? So again, so dito naman sa problem natin, parehong 50 amperes lang yung ginamit. Okay? But there are problems kung saan magkaiba yung ginagamit na field current for open circuit sa short circuit. Ang gagawin nyo lang doon, babaguhin nyo yung open circuit voltage. Ratio and proportion. Kasi remember, voltage is directly proportional to the field current. Diba? Same as the speed, actually. Diba? Dapat same speed lang. Kasi pag magkaiba yung speed, so yung magkaiba yung kanilang frequency. So therefore, magkakaroon agad ng pagkakaiba, diba? So sa values. Okay? Tama ba? So kaya kailangan nyo i-fix, diba? So pag magkaiba yung field current, saka magkaiba yung speed, diba? So anyway, so let's answer number 90. Okay? So again, troubleshoot. So this should be yung 220, gagawin natin 200 amperes. Okay? Tama ba? So now, so yung tatandaan nyo lang dito is that the synchronous impedance is the open circuit EMF per phase divided by the short circuit current per phase. Diba? So then this will be given by 1,730 volts divided by square root of 3. And again, so this should be only 200 amperes. So mas malapit yung lalabas sa 5 ohms. Okay? Tama ba? Pag 220 kasi lalabas sa inyo dito 4 point something. Diba? So ay malilito pa kayo with 4 kasi may 4 sa choices. Next number, 91. Zero sequence current will flow in a transmission line so when there is. Okay? So again, so remember dun sa choices natin. Okay? So itong letter A, so again, this is a balance fault. So wala tong zero sequence. Di ba? Yung line-to-line fault, positive saka negative sequence lang. Di ba? Walang zero sequence. Over voltage, di ba? So again, ang babaguhin lang natin dito is yung sa positive sequence, gagawin natin 1 point something or 0 point something, depende kung ano yung bago natin, gaano kalaki from the rated voltage yung over voltage. So hindi rin yung letter C, hindi guaranteed by the way, di ba? So again, pero sa letter D, so this is guaranteed meron tong zero sequence. Kasi nga pag double line to ground fault, di ba? So again, ito yung ating positive sequence, di ba? So this is the negative sequence. This is the zero sequence, di ba? So then these are just connected in parallel. So merong dadaan na current sa zero sequence natin. Okay? So kaya sagot natin dito is letter D. Okay? Next number, 92. No? surge impedance of 50 miles long. Underground cable is 50 ohms, so 25 miles length will be blank, no? So okay, so tatandaan natin na surge impedance sa characteristic impedance. And again, the characteristic impedance is basically yung nakikita natin na impedance of an infinitely long transmission line. So kaya kung 50 miles man or 25 miles yung length natin, diba? So again, as long as yung surge impedance as long as yung kino-consider natin sa surge impedance is the infinitely long line na nakikita ng line natin, di ba? So then that means that the surge impedance is constant. Okay? Tama ba? Kaya dito it doesn't matter kung 50 miles or 25 miles yung underground cable natin. Di ba? The surge impedance is always 50 ohms. Okay? So kaya sagot natin dito is letter B. No? Surge impedance is constant. So kasi kahit mabawasan, madagdagan ng 25 miles yung infinitely long, transmission line infinitely long pa rin siya. Di ba? Next, number 93. Diba? So number 93, this is RC circuit. Diba? So and this is discharging. Okay? So ibig sabihin, this is subsidence transient. Okay? Okay ba? So ganito yung circuit natin dyan. So we have a capacitor which is initially charged. So meron tong initial charge. So let's say the capacitance is C. Tapos kinonect natin across sa resistor. Diba? So ganito lang yung circuit natin. Okay? And yung hinahanap natin dito is the resistor voltage. No? So remember, for subsidence transient RC circuit, diba? So then, the resistor voltage is just equal to the capacitor voltage. This is equal to the initial voltage P raised to negative T over RC. Diba? Okay? So therefore, gagamit na lang ako dito ng ratio and proportion. Kasi dalawa yung given sa atin, diba? 10 volts saka 40 volts. So VR2 over VR1. So this is our initial voltage. So then E raised to negative T2 over RC. Diba? So then divided by, so again, initial voltage, so E raised to negative T1 over RC. Diba? So then cancel to. Okay? So then makikita natin, so na pag ni-rearrange natin, or pag sinubstitute natin yung given dito, so let's say VR2 is yung 10 volts, VR1 is yung 40 volts. So then, so again, so loss of exponent, so this will be E raised to negative of T2 minus T1, so then divided by RC. Diba? So pero itong T2 minus T1 na ito yung hinahanap natin sa problem. Yung amount of time para mag-decrease siya from 40 volts to 10 volts. Kasi remember, okay, base dun sa given sa atin, diba? So the initial charge is 100 micro. So therefore, solving for the initial capacitor voltage that is given by 100 microcoulombs, so again, so charge divided by capacitance. Diba? So this is given by 50 volts. Diba? Okay? That's our initial voltage. Kaya yung given sa atin na 40 saka papunta sa 10, so neither of this, diba, is the initial voltage. Okay? So kaya kung hindi nyo naisip yung ratio and proportion for this problem, diba? So most likely ang gagawin nyo dito is given the initial voltage of 50 volts, hahanapin nyo yung time, diba? So kung kailan siya magiging 40 volts, tapos yung time kung kailan siya magiging 10 volts, so then you subtract. Diba? So kaya basically, diba? So doon sa solution natin, yun na mismo yung T2 minus T1. Diba? So kaya so no need, diba? Sa akin to solve individually. So pwede pagsabayin na natin. So using ratio and proportion. Pero kung di nyo naman naisip to, so okay lang. Diba? So kasi kaya nyo to i-solve by solving T2 and T1 individually. So kasi nga alam natin na yung V0 natin is 50 volts. So we can solve that. Diba? So anyway, so again, so solving for delta T here, this should be equal to negative RC. So again, ano yung R natin? So we are given 100 ohm. So for the capacitance, we are given 2 microfarad. So micro means 10 to the negative 6, diba? So we have 2 times 10 to the negative 6 farad. Okay? So then this is negative RC, so times ln of 0.25. Okay? So this will be our delta T. Okay? So pag sinolve natin to, so we have negative 100. So then by 2 times 10 to the negative 6. Okay, so this is multiplied by ln of 0.25. So 10 divided by 40 is 0.25. Diba? So we get 0.277 milliseconds. Okay. So we have 0.277 times 10 to the negative 3. 10 to the negative 3 meaning milli, diba? So kaya this is 0.277. So again, we have milliseconds here. Okay? So kaya yung number 93 natin, so is letter B. Okay? Next, number 94. Okay? So for number 94, this is percent speed regulation. Sa voltage regulation, diba? Okay? So again, so this is given by the no load minus full load over full load. Okay? So multiply this by 100. Kaya yung given sa atin dito is 8.7%. So this is 8.7 divided by 100. The no load voltage, di ba? Yan yung hinahanap sa problem. Full load voltage given sa atin is 230 volts. That's full load over full load, that's 1. Okay? So the no load, so will be given by 230 volts multiplied by, so we have 1 plus 0.087. So you will get approximately 250 volts. Okay? So this is letter D. No? Number 95. So again, so we have a lamp. So let's say intensity I. So let's say at a distance of R. So again, directly mula doon sa surface natin. So with an illumination E. Okay? Tawagin natin as E1. So this is R1. Okay? Nakaka? So then, so the illumination here, so E1 is equal to, so we have I over R1 squared. Diba? So then, tinaas natin yung lamp. Diba? So again, so such that yung illumination natin so will be twice. Okay? And yung distance natin will be twice. Diba? So this is R2, so equal to 2R1. So then, kaysa ang hinahanap is yung bagong illumination. No? Okay? Nakaba? So then, so what will be the new illumination? So we can use ratio and proportion here. No? Okay? So again, so this is given by, so we have I over R1 squared. What will be the illumination here? So again, that's I over R2 squared. Diba? So again, this will be I over R2 squared. Okay? Nakaba? So kaya again, so pag sinolve natin to, so you will get, magka-cancel yung intensity. So kasi nga, pareho lamp lang kasi yung ginamit. So kaya dapat pareho lang yung intensity niyan. Diba? So then, okay? So again, so you will get, so that E2, so is equal to R1 over R2. So this quantity squared, so times E1. Okay? Nakaba? So which means that E2, so will be equal to, so again, what is R2? That's twice of R1. Diba? So then this quantity squared, the original illumination is 200 lux. Diba? So ay magka-cancel to. So then you will get, so original illumination is 800 lux. No? So this is 800. So 800 divided by 4, so this is 400 lux. Okay? So therefore, this is letter, 200 lux. Okay? So this should be 200 lux. So we have letter B. No? Okay? Next, number 96. No? Electrical safety month. Diba? So this is May. Okay? So again, so May. So ang nag-declare nito is si President Noynoy pa. Diba? Okay? So this is letter D. Okay? So ang alam ko presidential decree pa. So again, so this is under presidential proclamation. So or presidential decree 193. Okay? So again, series of 2011. Okay? Okay? Sa akin, so tandaan nyo rin to kasi lumalabas dito sa board. No? So lumabas yung board exam namin, April 2016. So ano daw presidential decree or anong declaration? So yung electrical safety month. No? Okay? So next, number 97. Okay? So ito na sa lecture natin ng power system. Diba? So if you remember this. Okay? So again, so yung equivalent reactance per unit, kasi percent lang naman yung kailangan natin. So is equal to the base power divided by, so given as 20 MVA, divided by the short circuit MVA. So given by 950. Diba? So again, this is the percent reactance. So this is S base. Okay, so S base over SF. So then multiply this by 100. Okay? So again, so this will be given by 20 megavolt ampere. So then this is divided by 950 megavolt ampere. Okay? So multiply this by 100, so you will get 2.1%. Okay, so this is the percent reactance. Okay? So this is letter C. So again, this is for a balanced fault only. Pero since wala naman sinabi sa problem, so we can assume that this is for a balanced fault. Okay? So next, number 98. Okay? Okay? So number 98, so current reactors, diba? So again, so are used to blank, diba? So again, so for current reactors, ginagamit natin yan to bring down, diba, the fault level within the capacity. So again, so remember dun sa equation natin, diba, so ng reactance, okay? So again, so this means that so again, so rearranging this, you will get that the fault power is just given by the percent reactance over 100 multiplied by the base power, okay? So baliktad, sorry, okay? So this will be the base power, diba? So divided by the percent reactance divided by 100. Okay? So kaya pag mas malaki yung reactance mo, mas mababa yung fault power mo. Diba? Kaya yung ginagawa ng series reactor, diba, is pinapalaki yung reactance. So hence, diba, so lumiliit yung fault natin. So this is to bring down the fault level within the capacity. So this is letter C. Okay? Next, number 99. Diba? So the main purpose of using core in a transformer, this is to decrease the reluctance. Okay? Nakaba? Kasi remember, the magnetic reluctance, diba, is given by 1 over mu. So times the length, diba? So of the core, so divided by the area. Okay? So ibig sabihin, sa akin, pag nagdagdag ka ng core sa transformer, lalaki yung permeability. Diba? Kasi pag wala kang core, the permeability is just equal to the permeability of free space, yung 4 pi times 10 to the negative 7. Okay? So pero pag gumamit ka ng core, nakamultiply yung sa mu r. So yung mas malaki yung permeability. So this is letter D. Diba? So yung number 100 naman, okay? So direct formula lang to. Diba? So kasi hinahanap sa atin yung voltage induced. Okay? Tama ba? So given sa atin yung frequency, given sa atin yung number of turns, given sa atin yung flux density, so and the area. So we can calculate the magnetic flux. So okay, so remember, so that, diba? So yung EMF natin is just 4.44. Frequency, number of turns times the flux. Diba? Okay? So 4.44. Frequency, secondary turns, so then we have the maximum core flux. Pero since walang given a maximum core flux then, so we will use maximum core flux density multiplied by that area. Diba? So dapat may cosine theta pa to dito. Pero again, ang assumption kasi natin sa transformer, so let's say ito yung core ng transformer. Diba? So again, so ito yung cross-sectional area. Diba? So then dumadaan lang yung flux perpendicular to sa area. Diba? So therefore, this will be 1. Okay? Tama ba? So kaya ito lang yung kailangan natin. So then from the given, so again, so the frequency is given as 400 Hertz. No? So the number of secondary turns is 70. Okay? Okay? So then, so the flux density, so is 0.9 Tesla. Diba? So and the area, so again, Tesla is Weber per square meter. No? So the area is given as 13 square centimeters. So let's convert this. So we have 1 meter for every 100 centimeter squared. Okay? So I cancel dito yung square centimeter, cancel yung square meter, so this Webers per second or volts. No? Pag sinolve nyo to, you should be able to get, okay? Solve natin. Okay, so we have 4.44 times 400 by 70 by 0.9, so by 13 divided by 100 squared. Okay? So we get 145.45. No? So therefore, so ang pinakamalapit sa choices is 150. Diba? So ang nakalagay lang naman sa problem is most nearly. Diba? Okay? So most nearly. So kaya we choose letter D. Okay? So any questions? Diba? So for PE. Okay? Okay ba? So again, so yan yung solutions natin sa electrical engineering. So again, kung meron kayo na-miss na mga problems sa lecture, so balikan nyo na lang doon sa i-upload ko na video. Diba? So again, so pinakamatagal niyan bukas na may upload ko yung lecture videos natin. Okay? Okay ba? So hindi kasi yan agad-agad available, diba, sa after ng meeting. So kasi parang pinaprocess pa ni Zoom. Okay? Okay ba? So,